Continuing with the series of understanding videos on the properties of normal distribution, in this particular session, we'll try to understand the most important property, which is the empirical rule. The empirical rule is basically a statement of how much area under the curve in terms of percentage is covered as we move away from the mean fixed standard deviation distances. One distance, sorry, mu, that is a mean plus or minus one standard deviation. If you were to go, how much area is covered? If you go away two standard deviations on either side, how much more area is covered? Three standard deviations, four standard deviations, and so on. So we stop at three standard deviations for most academic purposes. So before I demonstrate this using the Desmos, we will first try to understand the actual effect of changing the mu and sigma in a very visual manner. By now you already know that when mu changes, the location of the curve on the x-axis is going to shift either to the left or the right depending on the value of x. And if the standard deviation changes, the slenderness or the flatness of the curve is going to get impacted. So we will see that visually. So let me just generalize these values with mu and sigma instead of taking specific values. Let me remove this and paste it. Okay, so I can now add a slider to both. Now I can make mu to go between values that I want. Let's say I take a value between 100 to, let's say, 200. And the standard deviation, let's say it varies between 5 to 15. I'm just taking random arbitrary values. We'll now try to visualize what happens when we keep the standard deviation constant and keep changing the mean between 100 to 200. So as you can see, location is changing. I'm just trying to resize the graph. And now what I'll do is we'll fix the value of the mean at some place. As you can see, it is somewhere centered around 144. Let's see what happens when the standard deviation changes. The spread will change as expected. And just to make the animation a little more interesting, we'll try to run both the simulations. We'll run both the sliders. So now for every possible combination of mu and sigma between those limits that I have set up, you will notice that the normal distribution keeps fluctuating in its configuration. Let me stop it here. Now coming to talk about the empirical rule. The empirical rule is a rule which says that no matter what the shape and the configuration of the normal distribution, it could be a very flat one like this, or it could be extremely slender, tall shape like this. This particular rule applies very consistently. So let's go back to 300, or let's go back to any size that we want. We'll take this and resize it, and we'll see what is the meaning of this. Or maybe for ease of calculation, I would prefer to go back to 320. I'll keep the standard deviation as 20, and let's locate ourselves there. So now you see, if I were to change the value of the maximum value to, let us say, mu plus one standard deviation, which is 20, that is 300 plus 20, 320, I end up there, right? And let's say 300 minus 20 will be 280. So within this extent, you can notice that here you can read off the total area. Actually, it shows you the probability, which is proportional to area. You know that 68.26 is the area within one or plus or minus one standard deviation. Now if we move another standard deviation, adding 20 more and subtracting 20 from this, so we end up between limits 260 and 340, it is 95% of the area approximately, a little more, or close to 95.5% we can say. Now if we were to go to 3 standard deviations plus or minus on both sides, we will increase this to 360 and on the left side it was decreased to 240, so 360. So now you can notice that almost a very small area is still not covered here. So that still covers about 99.7%, nearly 100% of the area. For all academic purposes, we prefer to stop here for our calculations in the problems that we can encounter. However, it must be you must understand that in the real world, in the industry, in quality control or any process quality or product quality, mostly where it is used, people prefer to operate at Six Sigma levels. That means at 99.999997. So it actually translates to just about one defect in a million. So Six Sigma is going to be very common that you'll come across in the industry. So with that said, I would like to close this session. So I suppose that by now you have a good idea about all the properties of the normal distribution curve and the particular, and more specifically, you have been able to appreciate when I showed you the animated version of how the interplay of the mu and sigma when they change, how the deviation, how the distribution changes, and of course, finally, the empirical rule, how it applies to all distributions. I urge you to try to set up different distributions with different values of mu and sigma, change the values to one or up to these various levels of standard deviation, and check out the values of the area under the curve, and you will notice that it always very faithfully follows this rule. So that is about it. That covers, I think, all the properties that we wanted to talk about with respect to standard deviations. In the next videos, we will try to do some calculations based on certain problems. Thank you.